All right, this is going to be a review for test 2, and I hope that it helps you. Make sure you review it before the test. Just as a reminder, this is a review. So this covers um, the homework assignment chapter 3 practice test. All right. So I'm going to go over selected problems that I'll be using throughout, just because I'm not doing the whole entire thing. So question number 1. All right, so question number 1 says, determine whether the following equations define y as a function of x. Now, if you've done all your lessons, you've probably realized that this is a circle whenever you have y, x squared plus y squared equals radius squared, and that's circle. So then there's no way that this is a function because obviously it fails the vertical line test. So you can kind of think it in those terms. So this is going to be no. All right, for your answer on this one. Now, the next question we're going to go over is number 4. And number 4 says use the given graph. Okay, the domain is going to go from left to right. So it's going to be -3 inclusive. So -3 inclusive. And then it's going to go all the way up to 2 non-inclusive because of the value of that open circle. So that's what we're going to look for the range, or excuse me, the domain. The range is going to go from -5 up to 4, and that's going to be inclusive to both those values. So then we have inclusive -5, inclusive 4. Now the x-intercepts are going to be -2, but not 2. So just it goes all the way up to 2, but not including it. So then our x-intercept is just -2. The y-intercept is going to be at +4, and that is our answer for that. Okay. So now going over question number 8. Question number 8, it specifies the domain. Now this does not have a hard or closed or open circle, so then it's going to go from -infinity, because it's coming from -infinity, all the way up into and including 8. So there's our answer for that, -infinity to 8 inclusive. The range, it's going to go from coming from -infinity all the way up to +2 inclusive. So we have -infinity to 2. The x-intercept is going to be at 0 and at 8. All right, and an open interval of which the f is increasing is from -infinity all the way up to 4. So that's where it's going to be increasing. As far as decreasing, it's going to be from 4 down to that 8. All right, and now notice that it's not inclusive on any of those values. Okay, so be careful with how you put your parentheses. All right, now it's not constant anywhere, so D and E does not exist. And it says that right here up in the instructions. Open interval for which f of x, the function, is less than 0 would be from, now it would be from 0 on to infinity. So the way we write that is from -infinity, because we read it from the for the range value basically. So it's the function is coming from -infinity all the way up to 0. Okay, so it's coming from, so we specify the x values for all of which suffices or meets the condition. So now the open interval for which the function is greater than 0 would be from 0, all right, non-inclusive, all right, and it's going to be all the way to 8, okay, and notice not inclusive. Any x values which f has a relative minimum does not exist, all right. Now the value of relative minimum of f does not exist as well because there's no minimums. For where there's a maximum, there is a maximum and it occurs at 4, and the output value would be 2. So the next two answers are 4 and 2. So 4 and then 2. Now the input value of -4, you just go to -4, find out what that value is. It's -6, and you just go ahead and specify that it's -6. The x value for which f of x is equal to 2, so you're looking for the output value of 2 is going to be 4, because that's the input value that created the output value of 2. So that's how they want you to do it. So that's 4. All right. Is the f even, odd, or neither. Now this would mean it reflects over the origin if it's even, it would reflect over the x if it was odd, and it's neither of these things. So it doesn't reflect at all. So this one would be neither. All right, so this is the video support that can add help to this particular question. Number 10. Now it says determine whether the function is odd, even, or neither. This is reflective over the y-axis. So then when it's reflective over the y-axis, we look at it being even. All right, so we have, it's y-axis. So then we're looking at this one. It's neither because it doesn't reflect over the y, nor does it reflect over the origin. So then that's neither. This one reflects over the origin because if we bend this down and bend it over, that would be the determination of origin. So when it's reflective over the origin, then it's going to be odd. So remember that anytime it's reflective over y, it's even. Anytime it's reflective over the origin, it's odd. So then that leads us to question number 13. Question number 13 is a piecewise function. You go ahead and graph each function based off of the parameters. Now the parameter is at 0, so then that's the changing point. We go ahead and graph from the left side inclusive this function. So we're going to put a point here, and it's going to go down 1 over 1. So when we're looking at that, that means it's going to go up 1 over 1. And we're going to be doing a function. We do not want this entire bar, so we're going to clear that and make sure we select this one so we have only a segment. So we're going to go ahead and put a hard circle at this point because it's inclusive. Now we'll go ahead and come into when it's ever x is greater than 0. So you're going up to 4, and we want to go ahead and select this again to go up to 4, and then go up 2 over 1, because that's the slope, and this is going to be an open circle at this value. All right, and then the range is going to be from -4 up into infinity. All right, so we look at that, -4 to infinity, and it's inclusive. And then the value of output for 3 is going to be coming to 3. You're going to go up to here and see that it's 10. All right, so we're looking at 10. You can also do it by putting it, since that 3 is greater than 0, you can put 3 in here. 3 times 2 is 6, 6 times or plus 4 is 10. So that's the output value. So we look at the answer and we get it all right. Now, question number 14. And yes, this should be a review. It's not something that I should have to be writing every single little piece. I'm not teaching right now. I'm reviewing what questions you should be expected to answer. All right, now calculate the following inputs when you're given these values. So anything that's less than 0, we are going to use this function. So -3 is less than 0. Therefore, -3 times 2 is -6. -6 minus 2 is -8. 0 is equal. So then we're going to be using this function when it's equal. So 0 minus 7 is -7. We're done with that one. All right, now when we insert 3, 3 is greater than 0, so 3 minus 7 is -4. So that's what we're going to use to input that. That should move very, very quickly. You're just putting it into the function that answers the question. Number 17, write the point slope form of an equation of a line that's passing through these points. Now, when you do that, I will have to write the sum of this down. So we're going to go ahead and put down this. All right, so when we enter this, we're going to go ahead and remember to change the signs to this, and then go ahead and add our y's together, add our x's together. All right, and then simplify if we can. We can, so we're going to go ahead and put it into the equation. Now, the thing is that you can use, they want it in point slope form, so you're going to have to choose which point you want to use. I'm going to choose the first one because I don't care. So I'm going to go ahead and put y minus. All right, so minus, and then I'm going to put the opposite of that value. And then I'm going to go ahead and put in the slope. And then x, and then the opposite of that is 16. So then that's one of the answers that we can put in for that. So it's either or. All right, I chose the first one and I put in the answer there. Now it says write the equation in slope-intercept form. They want us to go ahead and distribute the value of that and go ahead and clean it up. So y plus 8, and then I'm going to distribute it to be negative 4 over 21x. And then we're going to have basically 16 and 21. They can't be reduced by anything, so we're going to go ahead and just multiply the top by 16, and that's going to give us what, 60? That's 24, so that's going to give us 64. 64 over, and that's positive because the negative times the negative is positive, and that's 21. Now we're going to go ahead and add 8, or excuse me, subtract 8 from both sides. So subtracting 8 from both sides, we take the value, and we need to give it, we need to have the value of 8 as our, or excuse me, 21 as the denominator. And if we take 21 and times it against 8, we're going to get 16, or excuse me, 168. And then we're going to go ahead and subtract 64 from 168 and get 104. Yeah, 104. So now it's going to be y equals negative 4 over 21x minus 104 over 21. And that's a pain in the butt when there's such big numbers. All right. So I gave you the right answer. Yes, thankfully, I did some mental math. I did some calculations. You can use a calculator to determine that, but don't get it mixed up. Don't get it. You're going to be expected to do something like that. All right. Number 18. Now it's parallel to this number, or this thing. It's a term of the equation that's parallel to this. So that means we're already dealing with a y equals, okay, negative 3x. Well, wait a second. They want us to go ahead and pass through the point of 7, negative 8. So we're going to, they want us to give us the point slope form. So then we're going to go ahead and put y plus 8 equals negative 3 times x minus 7. So that's the first answer that they want us to give. All right. Now the next thing they want us to do is solve it in terms of y. So we're going to go ahead and distribute the negative 3 to both parts, and then we're going to subtract 8 from it. So negative 3x, and then we're going to get negative 21, or positive 21, excuse me. Positive 21. Positive 21, and then you go ahead and take positive 21 and you minus 8 from it, and that's going to give us 13. So we're going to go ahead and put positive 13, and there's the answer we're going to put for here. All right, so my answer that we gave here is in fact lining up to that one. That's good. 19. The graph of the above is a transformation common to, common of a common or parent function. Identify the parent function. The parent function is an absolute value function, so that's going to be where you put the vertical bars around the x. The equation of the function is going to be moved to the right and moved down 1. When it moves to the right, it's subtracting 3, so it's going to take and be x minus 3, and then it's going to also move down 1 unit, so minus 1. So we have our answer here. Okay, so we're going to put that in there and we see the answer. Now we move on to 22. The parent function's giving, this would be inverted, okay, or reflected about the x-axis. So reflect over the x-axis, wherever that may be. I'm sorry. All right, reflect over the x-axis. It's be this one, all right, and then we're looking at it being vertically stretched, all right, vertically stretched by a factor of 3, not compressed, but vertically stretched. Compressed would be a fraction, by the way, and then we would be moving it to the left 7 units, So shifting the graph 7 units to the left and then down 3 units. So down 3 units. And those are all the 4 things that we would see here. Okay. So both the shifting, the vertical stretching, and the reflection. Now, to go ahead and graph that, I've encouraged you in the past, just go ahead and throw that in the graphing calculator if you need to. This is the parent function already graphed for you. Here's would be the value structure of that, which is indicated here. And you could go ahead and graph that. So that's how you would do that for this particular function. So for 23, you're looking at the quadratic. So it's going to be vertically stretched by factor 4. It's going to be moved to the right 6 units and moved down 3 units. So those are the 3 things that are happening to it. It wants you to go ahead and graph the transformation. All right. So then they're going to go ahead and graph it, and here it is. All right. This is a quick overview of what it is you're expected to be able to perform on the test. All right, now 27. It says the domain of the given function. Now remember that the domain of the given function for these kinds of functions, let me go ahead and use some more of this paper here. All you got to do is take the contents of the radical and then set that greater than or equal to 0. So then solving for that, we get this. All right, we're going to go ahead and get x is less than or equal to positive 6/7. So we're going to go ahead and say that since x is less than, we would come for the, it would be from negative infinity all the way up until 6/7 inclusive. So that's the answer we're looking for that. Sorry if you had to read sideways. Some of you are probably annoyed at me, but that's okay. I don't mind you being annoyed at me. I mean, you know what? Get over it. Ha 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 ha. Maniacal laugh. All right. Enough of that. Okay, now 29. All right, now the domain for that. Okay, the domain, all you got to do is set the denominator equal to 0. And then solve for it. Okay, well, in other words, factor. So what two numbers multiply together create 8 up and negative 9 would be 8 and 1, both being negative. And then we're going to go ahead and just say x equals 1 and then x equals 8. So now to write that, all you got to do is say, well, negative infinity all the way through 1, but then let's jump over 1, pick it up back at 1, go through all the way to 8, and then pick it back or jump over 8 and pick it back up and go ahead and go to infinity. So that's how you do that one. So that's going to be the answer for that. Okay. Number 30. Now this is dealing with arithmetic operations. We're going to go ahead and add the functions together. So it's going to be x squared minus 15x added to x plus 8, where these two equals negative 14x. And then there's our answer for that one. Now the domain for that is going to be all real numbers because of the fact that there is no restrictions on quadratics. So negative infinity to positive infinity when you say all real numbers. Subtraction is going to be x squared minus 15. And then it's going to be negative x minus 8. And then this is going to give us negative 16x's. So then that's the only difference in that. So we're going to put that as an answer. And then again, it's going to be negative infinity to positive infinity. The multiplication of this is defined as negative 2 or x squared minus 15x times x plus 8. And that's going to give us x cubed. And then we're going to get minus 15x squared. And then we're going to go ahead and get negative, what is that? Oh, positive 8 I did this a little backwards, but it doesn't matter. We're bringing these together anyway. All right, and then this is going to give us, I don't know what that is off the top of my head. 40, it's 40, and then that's 120. Yeah, I'll just put 120. I'm kind of guessing. Nah, I'm pretty confident in myself. 23 x squared, and there, by the way, there's an x here. Okay, and so we're going to go ahead and get x cubed. Let's go ahead and check the answer. X cubed, and then this is, oh, I added it, and it should have been subtracted because they're opposite signs. All right, so I did make an error. So then there's that, and then I did get that one right. Okay, so here we have that. So I added it accidentally. It's about seeing that this is negative and this is positive. They're opposite sign integers. You subtract. All right, now the value of an x cubed, there is no restrictions on those particular functions, so it's negative infinity to positive infinity. Now you go ahead and divide, so it's going to be this divided by this. All right, and there's no simplifying anything there. You can simplify by pulling out an x, but it doesn't make a difference, so we leave it as such. So our answer is going to be that. And then the restriction is that it's all real numbers except for where x equals 8 or negative 8. So we're going to skip over negative 8 by putting negative infinity and then doing all the things that we do, kind of like this one right here. We're going to just skip over negative 8. Now, I'm not going to write it for you. I'm just showing you the answer. All right. So that's question number 30. 32. Now, this is dealing with Fog and Goff. You're going to go ahead and plug f of g into, or the g of x into f of x, so it's going to be x minus 8 squared minus 7 times x minus 8. Now, hopefully they wrote this right, but I'm going to do it the right way. It's going to be x squared, and then it's going to be 16x plus 64. And then it's going to be negative 7x, and then plus 56. And then combining these two terms and these two terms together, we're going to get x squared. And then let me see if I can add that in my head. Then that's going to be 4, that'd be 3, that'd be 23x. And then this is going to be added together. That's going to give us positive 120. Yeah. All right, so that should be the answer we're coming up with there. So here we have that, but again, it doesn't give us the right answer. So, excuse me, I leave it to your will of how you want to properly put it in. I would caution you against doing what they just did here. I particularly don't like that. All they did was do this. And they didn't even follow it through. You're probably thinking, yeah, I'm going to go ahead and enter that. Go ahead and do it, whatever. As long as you get it right. But at the same token, you're not getting it properly right, in my opinion. All right. I've always been taught that you follow it through and clean it up. That doesn't make sense why they didn't do it. So anyway, so f into g. So f into g, you're going to put f, or x squared minus 7x in for x, and then minus 8. That's the answer we're looking for there. But again, it looks kind of goofy the way they put the dot between that, but it is in fact the same exact answer. Now you're going to go ahead and do the f of f. You're going to put x squared minus 7x in for the squared part, and then you're going to do the same thing here. You know what? Out of laziness, because they're doing it, I'm going to do it too, because now I'm being lazy. And that's the answer we're looking for here. Okay, I hate this jerky looking answer, but that's the exact answer I gave. All right. Now g of x, we're going to put, or g of g, excuse me, we're going to put x minus 8 in for the value of that x minus 8. And then this should clean up to being equal to x minus 16, but who knows what they're going to give. They didn't do that, so that's kind of, oh no, maybe they did. Oh no, they didn't. 2 times negative 8 is negative 16. I just don't know why they're doing this. This is weird. In my opinion, this looks so seriously weird. Okay, now you just go and take the 2 and you enter it into the value of right here, okay, or simply right what I have here. All right, and then you compute, and I'm going to leave you the ability to put that into a calculator if you have to. All right, so then put at 78, and then you put a negative 5 into the function of this. So negative 5 squared, and then negative 5 times 7, and then 9 minus 8. You can throw that in a calculator as well and get 52. I'll leave you to that. 33. Now it wants us to go ahead and find the inverse function of this. Now remembering that they want us to go ahead and graph this this right here, the identity function, and then they want you to graph it by just tilting your head. Basically, you get the following. Well, first of all, it's 5. It's 2, 5, so it's going to be 5, 2, and then it's going to be stretched like that. And there you have your graph, okay? So that's the function, okay? Didn't get shrunk or didn't get stretched or compressed, as the terminology has it. So, but anyway, that would be what we came up with our answer, okay? And then you're going to have to do all that. And then finding the domain of the function, all right, from 2 to infinity, the range from 5 to infinity, and finding that the inverse is the opposite. It's going to go 5 to infinity as well as 2 to infinity for the value of the inverse. So these should be absolutely mirroring each other. And that's your answer for that. Now for this one, using the distance formula, you're going to go ahead and take, and if you remember what I taught you in the lesson, then you go ahead and take the opposite of this one, add your y's together, and you're going to get negative 6. But remember, negative and positive doesn't matter. You're going to take the square root of 6 squared, and then add it to the value of 3 minus 1 is going to give you 2 squared. So you're going to get the value of 36 added to 4, which is going to give you square root of 40, which then you can clean that up as 2 square root of 10. So I think that that's what they're going to want. All right, and it is. All right, so you have to clean up your radicals. They don't want it. They don't want to round. They want you to simplify radicals if you need to. Okay. 38, midpoint formula. Look at that. This is just taking and straight up, don't change any signs or whatever. Just add your x's together, which is going to give you 2 divided by 2, which equals 1. And then it's going to be 4 added to negative 2 is 2 divided by 2 is equal to 1. Therefore, our midpoint formula is 1, 1. And that's it. All right, that's the answer. All right, and the last and final question that I'm going to review with you is question number 40. Now, what you do is you go ahead and you group your x's together, group your y's together, and use the completing the square. So I'm going to do that with you in a couple lines here. So we have, and remember what I did in the lesson, we're going to go ahead and use parentheses just to get us the format that we're looking for. All right, plus box. And those parentheses didn't do anything, you know, to change the value. It just changes its appearance. So now I go ahead and group the y's together. And then I put a plus box. I move the 17 over. Now I go ahead and since this is 6 and this is 6, I'm going to go ahead and take the half of that, which is going to give us positive 3 squared, and then half of negative 6 is going to give us negative 3 squared. And then I'm going to remember that I take both of these and add it to this. So I'm going to get 18, and then I'm going to go ahead and get 8, excuse me, it's 9 and 9, and I have 18. I'll do that right. I mean, my mind is so fast. 9 plus 9, all right? As it's 3 squared, that's what we would enter here, and then 3 squared is entered here. So then this becomes 18, and then this is going to become 1, because negative 17 plus 18 is 1. Now that means that our center is at negative 3, 3. Our radius is 1, because the square root of 1 is 1. So then we would go ahead and get the equation that I gave you right here, okay? And then the center, which I gave right here, and the radius, which I gave right here. And then you go ahead and graph that, and you get the following, all right, of negative 3, 3, center of a radius of 1. And that is all that you have there, okay? And that is the review, minus one question. I leave one question out there for you to have to solve without a review of it. It's something to do with the absolute value, okay? So anyway. Good luck with your studies, and that concludes all of the videos that are needed for it being successful on the test come this Sunday. All right, take care.